So here we are solving move zeros problem. So the problem statement says that we are given an integer array and we have to move all the zeros towards the end of the array, while we also have to maintain the relative order of the non-zero element. Okay. Also note that this thing we have to do in place without making a new array. Okay, let's see some examples. So the first example says that we have array with values 0, 1, 0, 3, 12. We have two zeros and those two zeros we have to push towards the end of the array. In the next example, we don't have any non-zero elements. We just have a single entry which is 0 itself. In that case, that will itself be our answer. Also have a look over the constraints. So the constraints clearly specify two things. One is there will always be at least one value and there will be positives and negatives in the array. So with this, the most straightforward approach that I can think of is we can basically do the counting of how many zeros are present in the array. Based on that count, we can actually update the resulting array. So what we will be doing is we will be traversing the same nums array and we will be changing the same nums array. So once we find that, okay, this is a non-zero element, so we will be pushing at the start. For the zero elements, we'll just loop the count how many times the zero is coming, and that we will be putting towards the end of the array. So this will be a very brute force approach, and if you will be presenting this to your interviewer will definitely ask you to optimize it. So here comes our next solution. We will be using two pointers along with swap operations. The idea is we will be keeping a pointer on the first zero and then the other pointer on the next index. So once we find that, okay, this is a non-zero element, at that point we will be actually swapping that. Okay, so with this way, in the whole traversal, at the end of that, we will be having our zeros pushed towards the end of the array. Stay tuned towards the end, because in the second approach I will be actually using ES6 this time. So let's move on to the code. I'll just increase the size of the code editor. Approach number 1. So here the idea was to maintain a count, right? So we'll directly create a counter and now we'll simply loop on the nums array. Okay. And if nums of I is actually equals to 0, if it is, so we'll just increase our count. Once we have our counter, now what we will be doing is, again, we will be looping on the same nums array. Okay, I missed the increment operator there. Okay, and now we will be actually checking if nums of I is not equals to 0. So in that case, we'll also maintain a counter along with this, which would be the j counter, because we need to push at the j index. So nums of j would be equals to nums of I, and after that we'll also increase the j, and I will be increased over here. This is a typo here. After this, so now as part of the third traversal, we have to traverse and put the zeros. So for that we can actually use a while loop, and we can make sure that count is actually greater than 0, and we can do a minus count after each iteration. Nums of j is equals to 0, and simply just update the j, right? So with this, I think this will be done. So we have done 3 traversal. Let's check against the custom input. So there's a typo here. We missed the if. So let's check now. Okay, it passes. Now let's submit this. Great. So the approach 1 brings us solution, but for obvious reason the interviewer will not be happy. Now let's move on to the next approach as discussed. So in the next approach, we will be first maintaining 2 pointers, and we need to point at that position where we have a 0, right? So in order to achieve that, what I will do is, first I'll start my loop from 0 to the nums dot length, and I will check if my nums of I, if it is actually equals to 0. So this is the point where I have to actually start my things up, right? So I can say, I can even take a variable called as let j only as -1 instead at the starting. And now if I find any zeros, any first zero, so basically I'll just update my j to be as the I, and I'll break here. Okay, else I think we can just continue. After the loop ends, we can check if my j is equals to -1. This means there was no zero found, so I can simply return, because there's no scope to push the zeros towards the end. What if we found something? So j will be having the first pointer, and now this is the time we will be declaring our second pointer, so which would be j plus 1. Why? Because j is pointing towards the first index, first entry, and now I need to traverse to the next entry so that I can actually do the swapping. So now we simply have to loop, and we will be checking if my I is actually lesser than the nums.length, right? And we will have to do a increment on I as well. So now what we have to do is we actually have to do the swap operation. So let me just expand this window as well. In order to do the swap operation, we'll use the ES6 way. So nums of I is comma nums of j, and here it will be nums of j, nums of I. This will do the swapping, and also after we do this thing. But yeah, before this, we need to make sure that this thing happens only when we have nums of I not equals to 0. So if that is the case, we have to do the swapping for this interval, and we also have to update the j pointer. So this should work, and now let's test out. Okay, nums.length, I missed the iterator. Okay, it passes the custom test cases. Great. So it's able to pass the main test cases also. Great. So let's analyze our code. So time complexity wise, here we are actually traversing 3 times. So the time complexity will be for sure order of n, and worst case order of n here, because what if we have all zeros in the array? In that case also we will be traversing this loop order of n times, so it will be order of n plus order of n plus order of n, which will be resulting to order of n. Okay, and what about the space complexity? So I do see the count variable, so which means order of 1 for it, and let's see if we have any other variables assigned. No, we don't have any other variables assigned. So in that case, order of 1. So let's move on to the next approach. In the next approach, let me just comment it and write second approach 2, and time complexity. So the time complexity in this one would be order of n. So this operation could be order of n in the worst case. Let's suppose if we have 1 0 present in the array, and that is 2 arranged at the last position. So in that case, this will be actually running towards the end. This will not actually run, right? In this case, if we have just 1 0 and that is itself at the last, so then I equals to j plus 1, this will actually not have any impact. But yes, order of n definitely. So in all the cases, if you would be analyzing this approach, it would be order of n only. And let's calculate the space complexity. So space complexity also order of 1. We do have variables written, so I think the same space complexity. Okay.